Welcome guys to a video on HCF and LCM part 2. I hope you have watched part 1 of the series. Please do watch part 1 of the series so that you will understand this part thoroughly. So basically HCF means highest common factor, or it is also called as GCD, that means greatest common divisor, while LCM means least common multiple, that is the smallest number that is divisible by each of the given numbers. Now let's understand what HCF and LCM exactly means. HCF or GCD, that is highest common factor or greatest common divisor. Now in a fraction, say x upon y, we know x is called as the dividend. The numerator is the dividend and the denominator is the divisor. So when we are asked to find the HCF or GCD, greatest common factor, greatest common divisor, we are supposed to find the denominator of the fraction. So they give us the dividend, say two dividends they have given, x1 and x2, or say three dividends they have given us, and they want us to find the denominator such that this denominator is common for all this dividend and it is the highest number that will divide this dividend thoroughly, exactly. There won't be any other number other than this y. There won't be any other number which will divide the given dividends thoroughly. There would be a number smaller than y which will divide this dividends, but there won't be any number greater than y which will divide the given dividends. That is what is meant by finding the HCF. So HCF means we are finding the divisor for the given numbers such that that divisor is the highest common divisor. And LCM means the smallest number that is divisible by each of the given numbers. Here we are supposed to find the LCM, means we are supposed to find the dividend. This should be divisible by given numbers. So they would be given us say two numbers y1, y2 or y3, and they want us to find the numerator. So dividend, here we are supposed to find the dividend such that this x is smallest number which is divisible by each of these given numbers. There won't be any other number other than x, any other number smaller than x which is divisible by given numbers. Okay, there would be a number greater than x which is divisible by the given numbers, but we need to find a numerator or denominator such that it is the smallest number which is divisible by the given numbers. So this is what is meant by LCM. LCM means the smallest number that is divisible by each of the given numbers. And HCF means the highest common factor or greatest common divisor. So HCF means we find the divisor and LCM means we find the dividend. So now let's see what is the method to find the HCF and LCM. Now let's consider with examples how to find HCF or GCD using prime factorization method. That means the factors we will be considering will be the prime numbers. We have understood now HCF is the greatest common factor or divisor that divides the given numbers exactly. That means we are supposed to find the denominator, the divisor. Suppose these are two numbers, say 24 and 32. Now we need to find a number which will divide these two numbers thoroughly, exactly, and that number should be highest number. There won't be any other number greater than the number that we found which will divide this given numbers. Okay, let's see how we do. So 24 is the dividend, okay, and we need to find the divisor. So 2 times prime number, we'll consider prime number. So 2 times 12, 2 times 6, 2 times 3, and then 3 times 1. So all these are the factors of 24. So we'll write down here. Now 32. 32 is the dividend. We'll find the prime divisors. Right. So 2 times 16 is 32. 2 times 8 is 16. 2 times 4 is 8. 2 times 2 is 4 and 2 times 1. So till we get 1 we proceed. Now all these are factors of 32. We found the factors of 24 and 32 separately. Now we need to select the numbers which are common in both the numbers. So 2 is common to both the numbers. This 2 is common. This 2 is common. Right? We do not have any 3 here. Neither do we have any 2's here. Right? So the HCF of 24 and 32 is 2 into 2 into 2. 2 2s are 4, 4 2s are 8. So 8 is such a number which will divide 24 and 32 exactly, and there won't be any other number greater than 8 which will divide both these numbers exactly. Okay, so there would be any other number smaller than 8, say 6, 4, which will divide these numbers thoroughly. But there won't be any other number greater than 8 which will divide the two numbers thoroughly. So this is how we find the HCF of given numbers. Let's have another example. Here we have three numbers, 717, 315, 588. So we'll start with 717. Now for HCF and LCM, you should be thorough with your tables. So 7 times 111 and then 3 times 37. 37 is a prime number, so 37 times 1. So now these are the factors of 777. So we'll note down here. Next is 315. So we'll start with 3 as a prime number. So 3 times 105. Then we can consider 5. 5 times 21. Then again we can consider 3. 3 times 7. And then 7 is a prime number. So 7 times 1. Okay. So now all these are the factors of 315 and we will note down here. Next is 588. It is an even number. So we'll start with 2. 294. Then again even number, so 2 times 147, this will go in 3, 3 times 49, 49, 7 times 7 is 49 and then 7 times 1. So factors of 588 are all these numbers. Now we need to find numbers such that they are common to the given numbers. So 7 is common in all the three numbers. Also 3 is common in all the three numbers. Okay. Here 2 is common, but it is common in only two numbers. We don't have any 2 here. Okay. So when we have three numbers, we have to take care that the numbers are common to all the given numbers. Now HCF of this will be 7 into 3, that is 21. What it means? That means if we divide 777, 315 and 588 by 21, it will be exactly divisible and you cannot find any other number greater than 21 which will divide this given numbers. Okay, there would be a number smaller than 21 which will divide these numbers thoroughly, but you will not find any number greater than 21 which will divide these three numbers exactly. Okay, so this is how we find the HCF. Now here we have taken this number separately. Right, you can also take them simultaneously and proceed. So same prime factorization method will consider the given numbers simultaneously. Now in the first case 24 and 32, you will end up with the same answer, 2 times 12 and 2 times 16. Now here you should consider a number which is common to both the given numbers, right? So we need to consider prime number which can divide both this dividends. So 2 times 12 is 24, 2 times 16 is 32, 2 times 6 is 12, 2 times 8 is 16, 2 times 3 is 6 and 2 times 4 is 8. Now here what happens? 3 and 4. We can't have a number which will divide both these numbers simultaneously. So we will stop here. So this becomes the HCF. So these numbers 2 into 2 into 2 are the highest common factor for 24 and 32. That is, the answer is 8. Okay. We will stop for HCF. We will stop when we won't have a common factor for this dividends. Now next is 60, 12 and 36. So once again we can start with 2. So 2 times 30, 2 times 6, 2 times 18. Once again you should be thorough with your tables for HCF and LCM. So 2 times 15, 2 times 3 is 6, 2 times 9 is 18. Now here we can consider 3 as the factor, 3 times 5, 3 times 1, 3 times 3. And now here we won't have a number factor which will divide this number simultaneously. So we will stop here. So factors of 60, 12 and 36 are 2 into 2 into 3, that is 2 2s are 4, 4 3s are 12, and 1 obviously is a factor. 1 will be a factor common to all. Next is 56 and 57. Now here in this case, we cannot have a number which is common to both this, which will be able to divide these numbers simultaneously other than 1. 1 times 56 is 56, 1 times 57 is 57. So here the highest common factor will be 1. So this is another method where we take the given numbers simultaneously and see that the factors are common. If the factors are not common, we will stop. That becomes these factors, the product of these factors then become the HCF for our given numbers. Now another method is the long division method. Say for example 56 and 77, first example. So here when we have two numbers, we'll take the smaller one as the divisor and the bigger one as the dividend. So here 57 becomes the dividend and 56 becomes the divisor. So 56 times 1 is 56. So you have a remainder 1. Now you divide this one, the remainder 1 becomes now the divisor and 56 becomes the dividend. So this is how it becomes 56. So till we proceed till we get the remainder 0. So this is how you should proceed. You should proceed till you get the remainder 0. This remainder now becomes the divisor and this divisor becomes the dividend. Okay, so HCF of 56 and 57 is the last divisor that you have, that is 1. Okay, now let's understand better with three numbers: 777, 315 and 588. Here again the smallest number will be the divisor, a greater number will be the dividend. Okay, so this one pair will consider, then whatever divisor we get here, HCF we get here for these two numbers, that becomes the divisor for the largest number. So we'll start with 315 and 588. So here we'll say 315 times 1 is 315. We subtract it, we get 273. Now this 273 becomes the divisor and 315 becomes the dividend, right? The remainder becomes the divisor. So 273 times 1 is 273. So 42 is the remainder. Now this 42 becomes the divisor and 273 becomes the dividend. So this is how it proceeds. 42 times 6 is 252. So the remainder now is 21. Now this becomes the divisor and this becomes the dividend. So we proceed here. 21 times 2 is 42. We got this as 0. So now this 22, the last divisor, becomes the HCF of the given two numbers. So here 21 is the HCF of 315 and 588. Okay. Now we still have another number. So this 21 becomes now the divisor and the last number becomes the dividend. So 21 is divisor and 777 is the dividend. So we start with 21 times 3 is 63. So 147. Now this 147 becomes the divisor. 21 times 7 becomes 147 and then we have 0. So now this becomes the HCF of all the three numbers. That is, the last divisor becomes the HCF of all the three numbers. When we have three numbers, this is how we proceed. This is a long division method. So we have two methods for finding HCF. One is prime factorization method, another is long division method. In prime factorization also, we either take the numbers separately or we take them together. Now next is finding the LCM. LCM we know the smallest common number that is divisible by each of the given numbers. That means we are given the denominator and we need to find the numerator. So consider example 60 and 48, first example. So we'll consider them simultaneously now. Once again we'll proceed the same way taking prime numbers. So 2 times 30 is 60, 2 times 24 is 48, then 2 times 15 is 30 and 2 times 12 is 24. Now here you can consider 3 times 5 is 15 and 3 times 4 is 12. Now in this case we consider dividing all the numbers till we get 1 for each of these numbers. Okay, if it was HCF then we would have stopped here. We needed common factor. Here it is not so, least common multiple. So here I will have a separate divisor till I get 1 for both the numbers. So I consider here 2 times 2 and bring down 5 as it is. So 2 times 1, bring down 5 as it is, and then 5 times 1. So here we proceed once again. Even if we have separate factors for the dividend, it is fine. We continue the same way and bring down which is not divisible. Okay, till we get 1 here. So here now the LCM for 60 and 48 is all these factors, the common as well as the uncommon. And what it means, this 240 is the smallest number, common number, that is divisible by 60, the given number 260 and 48. So we have found a number, the smallest common number, that is divisible by each of the common given numbers. So this is what we mean by finding the least common multiple. So in LCM we find the dividend and in HCF we find the divisor. Now let's have another example, 12, 15 and 45. So we start with 3, 3 times 4, 3 times 5 and 3 times 15. Now here you can see you can either take 2 or you can take 5 or you can take 3. Any number as a factor is fine. The rest you can bring down as it is. So we'll consider 2. 2 times 2 and bring down 5 and 15, then again 2 times 1 and bring down 5 and 15 as it is. Now here I can take 5, 5 times 1 and 5 times 3 and then 3 times 1. So we continue till we get 1 here. Okay, so now these all common as well as the uncommon factors are the LCM for the given numbers. That means what? If we divide 180 by 12, 180 by 15 and 180 by 45. So 180 is divisible by each of these numbers thoroughly, and 180 is the smallest number. You cannot have a number smaller than 180 which will be divisible by all the 3 numbers, all the given 3 numbers. So we are finding the dividend. One more example, 105 and 91. So we'll start with 7, 7 times 15 and 7 times 13. Once again, you need to be thorough with your tables, multiplication. Now here we'll start with 3, 3 times 5 is 15, get down 13. Now 5 times 1, get down 13 and then 13 times 1. So this is what we got. So here common as well as uncommon factors are the LCM of the given number. So we have now 7 into 3 into 5 into 13 as 1365. That means 1365 is our dividend and it is divided by 105 and 91. So this is what it means. This is a common number, common dividend, which is divisible by each of the given divisors. I hope it is clear. You need to do a practice. Please do practice so that the concept will be clear. HCF means finding the denominator. LCM means finding the numerator of a fraction. Now let's see whether you have understood. Please find the HCF of these 3 numbers, 403, 434 and 465. And another is 57, 75 and 102. Please find for yourself the HCF and LCM for 16, 28 and 40, and another is 63 and 81. So hope the concept of HCF and LCM is clear. With practice it will be clear. Moreover, you should be thorough with your tables. and practicing more and more examples. So do find HCF and LCM for yourself. That's all in this video. Do like, share and subscribe the channel for more such videos. There is part 3 of the series. Please do watch part 1 and continue watching part 3 of the series. Thank you.